Okay, we're going to spend some time looking at something called a unit vector. A unit vector, well, the word unit meaning one. A unit vector is a vector of magnitude 1. So remember that the magnitude is just the size, so of magnitude 1, and is parallel to an associated vector. Okay, so let's try an example one. The first thing it says on the side is, remember that if you've got a vector A, which has got the components x, y, then a vector B, which is equal to a constant times A, will be parallel. Okay, so they will be parallel, and the reason being is because they're related by multiplication of a scalar. So multiplication by a scalar, think about it as multiplication by a constant. If you've got a vector and you multiply it by a constant value, you'll get a vector of different length but parallel. Okay, for example, the vector 2, 4 would be parallel to the vector 4, 8, since the vector 4, 8 is double 2, 4. Or, for example, minus 1, minus 2 would be parallel to both of them, because that would be minus a half lots of that vector. So if it's related by multiplication of a scalar, it's going to be parallel. So let's go for an example 1, which is going to be to find the components of the unit vector V which is parallel to the vector U, which is equal to 3, 4. Okay, well, the first thing is we need to investigate the magnitude of 3, 4, so that is going to be the square root of 3 squared plus 4 squared, and that is the square root of 9 plus 16, which is square root of 25, which is equal to 5. So the vector U has got a magnitude of 5. The vector V has got a magnitude, then it is 1/5 of that, because 1/5 of 5 is obviously 1. So vector V then is going to be 1/5 of vector U. So that's then 1/5 of the components. So 1/5 of the components then is 1/5 of 3, 4. So then the resultant vector, then just multiply both components by 1/5. It's going to be 3/5 for the top component and 4/5 for the bottom component. Now, just in this one occasion, it's not something that's really required of us, but what I'm going to do is just check that that is then a vector with magnitude of 1, so that would be the square root of 3/5 squared plus 4/5 squared. Remember, square a fraction, square top and bottom, so that's the square root of 9 25ths plus 16 25ths. That's the square root of 25 25ths, which is square root of 1, which is equal to 1. Okay, so how do we do it again? Right, so your first move is the vector that you've been given, find its magnitude. We found that the magnitude of that vector was 5. Our vector then is going to be 1/5 of that size, and it's 1/5 of the vector 3, 4. It's related by multiplication by a scalar, so it must be parallel. And then 1/5 of 3 is 3/5, and 1/5 of 4 is 4/5, and that is my vector V, which is the unit vector. Let's try another one. So this time we're going to find the unit vector which is parallel to the vector Q, and I'm going to say that the vector Q then is -6, -8. Okay, so the vector I'm looking for then is T, and I need to find the components of T, and that's the unit vector related to Q. So let's first of all find the magnitude of Q. So that's the square root of -6 squared plus -8 squared. That's the square root of 36 plus 64. That's the square root of 100. Square root of 100 is 10. So therefore, the magnitude of the vector q is 10. That means that the vector t then is 1/10 of the vector q. Okay, so that's going to be 1/10 of, well, what's the vector q? It's minus 6 minus 8. So let's put that in then. So that's going to be minus 6/10 minus 8/10. But I would absolutely simplify that down to minus 3/5 minus 4/5, and that is the final answer. Let's try an example 3. Okay, so example 3, let's go for this one. Okay, we're going to find the unit vector P, which is parallel to the vector Q, and here's the components for Q then. So what we're going to say is that the components of Q then is minus 4, 6. Okay, first move, let's find the magnitude of Q. Square root of minus 4 squared plus 6 squared. That's the square root of 16 plus 36. That is the square root of 52. Now, at that point, the square root of 52, that's something that I can do something with. Like, can I simplify it? Yeah, I can. So that's definitely a surd that can be simplified. Now, remember, in terms of simplifying surds, what am I thinking at that point? Well, you need to get your square numbers up, first of all, between 1 and 100. That's a good start. And we are looking for the biggest number on the list, which is going to be a factor of 52, and that number, maybe takes a wee bit of thought, but that number is there, and it's definitely 4. Many times is 4 going to 52? Just have a wee think about that one. That number is 13. Okay, so it's going to be the square root of 4 times the square root of 13. The square root of 4 is 2 root 13. Okay, right, so the vector t then, right, that's going to be 1 over 2 root 13 lots of the vector minus 4, 6, which was the vector q. So let's put that in then. That would be minus 4 over 2 root 13 and 6 over 2 root 13. So a wee bit more of a messy result this time, but still pretty easy. Right, so minus 4 over 2 is minus 2. I can simplify that down to minus 2 over root 13, and 6 over 2 is 3, and that's going to be 3 over root 13. Final answer.